Yes, sir. You may please start, sir.
Thank you, sir. Hello everyone. Yesterday we were discussing about how applying the derivatives, application of derivatives, we can check the rate of change of quantities. Okay, so quantities that were quite complex, that had got no relation. We did not have the direct relation of them as a function. Okay, we did not have the quantities as a function of time, but still we were able to calculate the rate of change of those quantities using the rate of change of something, some variable that was related to them, right? So yesterday, for example, we saw that circle. Okay, so just a second. So hi, so yesterday, as we were doing it, for example, you have a quantity Q, okay, and you need to calculate the rate of change of quantity. So rate of change of quantity would mean that how the quantity is changing with respect to time. Okay, that is meant by rate of change of quantity. So if it's dependent on quantities X and Y, okay, and both of these are themselves dependent on T. So you applying chain rule, you can do it. Okay, that is what we had done yesterday. So let us just directly move on to the homework problem that I had given you. So we were discussing about a cone. Okay, about a cone. Ashrita, can you tell me what will be the volume of this cone with respect to the volume of this cone as a function of its radius and height? What is the volume of the cone? Gayatri, can you tell me what is the volume of the cone we had discussed yesterday? I hope I'm audible. Hello, hello.
Yes, sir, you're audible.
Yes,
Okay,
sir.
okay, thank you. So can you just tell me what is the formula for volume of the cone?
1 by 5
Great,
pi
great, correct. Right,
Yes, sir. Yes,
right.
sir.
So if I ask you to differentiate this thing with respect to V, so what is happening is my radius and height both are changing. Okay, both my radius and height are changing. Okay, so I need to calculate the value of my dV by dt. Okay, so I need to calculate what is the rate of change of my this thing. So it will become pi by 3 into d by dt of r square h. Can you tell how we can differentiate r square h? How will we differentiate r square h?
Product rule.
Okay, great. Product rule, correct. So it will be pi by 3 into. Can you tell me what will be the derivative of r square?
2R, sir.
2r into. We are differentiating it with respect to t, right? So it will be chain rule multiplied by dr by dt also
Yes, sir.
plus r square as it is and dh by dt. Correct, right? I hope all of you got it.
Yes, sir.
Just basic chain rule. So just by inputting my values, what is the rate of change of radius and rate of change of height, I can easily tell you what will be the rate of change of volume at any given point. Correct? Got it, everyone? Okay. So I just have one small thing to discuss with you. See, generally what happens is if a quantity is increasing, so we denote it as positive. Okay. Because it is changing with respect to time. With increase in time, the change is positive. Okay. So that is why. So for example, I tell you dr by dt. Okay. So if my time is moving ahead, my time is increasing, my radius is increasing. So increase in quantity will be represented as positive. Same way, decrease in quantity with respect to time will be treated as a negative value. Okay. Right? Because obviously, if my time is moving ahead, my radius is uh, going below. So my value of dr by dt or anything that is decreasing will be a negative value. Okay. So let us just have a small question on this. So let us obviously go with the basic question. So you have got again a circle, and this time the radius is decreasing. Okay. The radius is decreasing. So the radius currently is 5 centimeter, and the radius is decreasing at the rate of 0.1 centimeter per second. Fine. And you need to tell me what is the value of dA by dt. Okay. The rate of what is the rate of change of area? So can you just tell me what will be the value of dr by dt? Rate, what is the rate of change of radius? How fast is the radius changing? It is already given to you, right? 0.1 centimeter per second.
Yes, sir.
So I should treat this value as negative because it's decreasing, right? Shouldn't this value because it's decreasing? Tell me. Should it be a negative or a positive value?
Negative, sir.
Who will tell me? It's a negative value, right? Because it's decreasing. See, decrease in quantity is a negative value. Fine. So can you tell me what is the value of dA by dt? So dA by dt is basically d by dt of area can be represented as pi r square. So this thing will be 2 pi r into dr by dt. Fine. So dA by dt can be written, the value is 2 pi into r. R is how much? 5 centimeter into
Yes, sir.
0.1 centimeter per second. So my final answer is how much? Pi centimeter square per second. Right? Pi centimeter square per second. This is my answer. Fine. Everyone? Okay, so there should be a minus sign, right? So minus pi centimeter square per second.
Yes, sir.
So can you tell me what is the significance of this minus in the answer? What does the minus tell you in the answer? What is meant by the word minus in the answer? So minus denotes that area is decreasing. Okay, this is what is meant by the word minus. Minus means that area is decreasing. If area is not decreasing, what will happen? I mean, if the radius is decreasing, obviously the area will also decrease, right? See, the radius is decreasing, so it is quite evident that the area will also decrease. That is why we have a negative sign in the answer. Fine. So let us try one more case in which things are not as usual. So you have been given a rectangle like before, okay? Earlier you had a rectangle. Again, length is x, breadth is y. Okay. So at some point, x is 10 centimeter and y is given to you as 6 centimeter. Okay. And the length is decreasing. At 3 centimeter per second. Okay. Length is decreasing at 3 centimeter per second and breadth or the width is increasing at 2 centimeter per second. So basically what is happening is one dimension is growing lesser, the other is growing. Okay, so like one, it is growing thinner on one end and growing in one end. So now if I ask you to comment on its area or perimeter, you can't just directly say. Over here, what was happening is you already knew that if the radius decreased of a circle, the area will also decrease. So you already knew the sign of dA by dt on itself. But this time it is not that evident. So it is asking you the rate of change of perimeter and area. Fine. So let us go for perimeter first. Can you tell me what is the perimeter? It is 2 into x plus y, right? We did it yesterday. Perimeter is x plus y. If I differentiate this thing with respect to t, can you tell me what will be the right hand side? What will be the right hand side? It will be dx by dt plus dy
dx
by dt,
by
right?
yes, sir. Yes, sir.
Right? Right? So first, can you just tell me one thing? If the length is decreasing and the width is increasing, can you directly comment whether the perimeter or area is increasing or decreasing directly without looking at the question? Or do we need to solve it first? What do you feel? See, in the circle, it was really easy to think. If the radius will decrease, definitely I can say that the area will decrease. But over here, we have got two dimensions. So what do you feel? Do we need to solve or I can directly say?
We should solve, sir.
Yes, correct. Because there are two dimensions, right? Not one dimension.
Yes.
Only if one dimension was changing. For example, I kept my x constant. I kept my x constant, okay? And I told you that my y is increasing. So I can directly say that, sir, x is constant and y is increasing. So I can directly say that my area will increase. But over here, two dimensions. So I will need to operate on two dimensions. Let us see. So 2 into dx plus dt is how much? Dx plus dt is, tell me, how much is dx plus dt? Dx by dt. Rate of change of length. What is the rate of change of length? It is minus 3, right? Length is decreasing at 3 centimeter per second plus dy by dt is 2 centimeter per
2
second. So how much is my final answer?
minus 2 centimeter per
2
second.
centimeter by second, sir.
Minus 2 centimeter per second. Great. This is my rate of change of perimeter. Now, what about area? Area can be written as x into y, right?
X
So
into
dA
y.
by dt, dA by dt can be written as, tell me, how will you differentiate x into y? What is the derivative of x
Product
into y?
rule, sir.
Product rule, great. So apply product rule, it will be x into dy by dt plus y into dx by dt, correct?
Yes, sir.
Okay, great. So let us try to solve it. So again, if I need to calculate my dA by dt, x, the value of x is given to me as 10 centimeters. So 10 centimeter into dy by dt is how much? Tell me. Value of dy by dt is
2,
2
sir.
centimeter per second plus y. Y is how much?
6
6. And what about this?
minus
Dx
3,
by
sir.
dt minus 3. So 20 minus 18, how much? 2 centimeter square per second, right? Everyone
Yes, sir.
got it? Got it, everyone? So over here, the perimeter is decreasing. The overall perimeter is decreasing. It is minus 2 centimeter per second. It is decreasing, right? But what about area? Area is increasing. So that is why we can't directly comment on perimeter and area just by looking at one variable. Because there are two variables involved, so we will need to solve the question. Fine. Okay. So let us give a try on a 3D case also. Let us see how we can do 3D questions also related. So since we were talking about cone, so let us just try with a cone. Okay. So what is happening is I have got a pipe, I have got a tap. Okay. This tap is pouring out sand, and below on the ground, a cone is being formed. Fine. It happens, right? It gets mounted in a cone shape. Sand, it is sand. Okay. So it will get accumulated in a cone form. And the rate of falling of this sand is 12 centimeter cube per second. Okay. The tap is giving me sand at 12 centimeter cube per second. The this falling sand forms a cone on the ground in such a way. Okay. So this cone has a particular shape. This cone has been given a particular shape that the height of the cone is always 1/6 of the radius. Height of the cone is always 1/6 of the radius of the cone. Okay. So the cone will always retain its shape. Okay. The cone will always have this shape only. So it is asking you how fast is the height of the sand cone increasing. So it is asking you the value of dH by dt. When its height is 4 centimeters. Okay. So there will be a point. See, since obviously this will start from zero height, right? Initially there was no sand. So it will start from zero height. The height will slowly keep increasing, and there will be a point when its height will reach 4 centimeter. So when its height is 4 centimeter, it is asking you what will be the rate of change of height. That is what it is asking. How fast will the cone change? Okay. So let us give it a try. So can you write the volume of this cone? Volume of cone is pi by 3 r square h. Since I am being asked h by t, so I should convert this whole thing. I should convert this whole thing only to h. Can I do that? Yes, I already know r is equal to 6h. So I will substitute r is equal to 6h in this equation. So it will be pi h by 3 into 6h whole square, right? 6h whole square can be written as 36h square, correct? So overall my value becomes 12 pi h cube. Everyone, do you agree with this? See, the shape is already given to me. The, the cone will always retain its shape. The shape of the cone is always such that height is 1/6 of radius. Okay. So I can just directly write it in terms of h. I could have written it in terms of r also. If you think, I can write this thing in terms of r also. Let me see. Let me show you how I can do it. So r square into. So I can write h as r by 3. So it will be into r by 6. So it will become pi r cube by 18. I can do it like this also. But the issue is I am being asked the value of dH by dt, not the value of dr by dt. If I differentiate my v with respect to t, I should be getting a term of h and a term of dH by dt. So in order to do that, my function should be in terms of h, right? If I have a function of r, it will give me a term of r. So that is why this thing won't work. Okay. So can you just tell me what will be my value of dv by dt? dv by dt would mean dv by dr, sorry, dv by dh into dh by dt, right? Can you tell me what will be my value of dv by dh? The derivative of 12 pi h cube. 12 pi h cube. What is the derivative of 12 pi h cube with respect to h? Like, it is really basic, right? It will be 36 pi h square
36 h square. Yes, sir.
into dh by dt, right? I don't know why did it take so much time. Fine, correct? 36 pi h square.
Yes, sir.
And it's already been given to you that h is 4 centimeter. So you know the value of dv by dt also? How fast is the volume of the cone changing with respect to time? The rate of change of volume, do I know that? Tell me. See, I am being asked the value of dH by dt. I know a particular value of h. Do I know the value of dv by dt also? Yes, I know. Where is the sand coming from? The sand is coming from the tap, and I know how fast the tap is sending me sand. So it's 12 centimeter cube per second, right? Because the sand is only coming from the tap. So 36 pi h square. H square is how much? 16 centimeter square. Correct? Into dH by dt. So can I calculate my value of dH by dt now? Everyone?
Yes, sir.
Right? So all that is left is just a little bit calculation that I need to do. So it will be 1 by 48 pi centimeter per second. It's really slow, right? 1 by 48 pi centimeter per second. Correct?
Yes, sir.
Yes, sir.
Okay. Okay, fine. Correct. So, fine. Let us give one try in case of implicit function also. In case of implicit function, let us give a try of how you can find the rate of change of implicit variables using chain rule, using derivative. Okay, fine. So what is happening is you have got a ladder. You have got a ladder leaning, something like this. This ladder is given to you. See, this is both of these are perpendicular things. Okay, but these both of these walls are perpendicular. So this is the floor. This is the wall. Okay, and you have a ladder that's 5 meter long. Fine. You have a ladder that's 5 meter long. This 5 meter long ladder is leaning against a wall. Okay. The bottom of the ladder is being pulled around the along the ground. So what is happening is this, I have got something tied to it and I'm pulling it to the right hand side at the rate of 2 centimeter per second. Okay. So this thing is being pulled at 2 centimeter per second. So it is asking you how fast is its height on the wall decreasing. So how fast is this point coming downwards? Obviously, if this point is being pulled to the right, this point will come downwards only. It is quite evident. Okay. When it is given to you that the foot of the ladder is 4 meter from the wall. So basically this thing is given to me as 4 meter. And it is being pulled at 2 centimeter per second. Fine. Can I give it a try? Can I establish a relation between both of these lengths and my length of the ladder? Can I do that? So what I'll do is I'll treat this thing as X and I'll treat this thing as Y. Can I establish a relation between X, Y, and the length of my ladder? Pythagoras theorem.
Yes, sir.
Everyone, tell me what will it be? What will be the relation between length of the ladder and X and Y?
5 equal to under root x square plus y square.
Okay, or in other words, X square plus Y square is equal to 5 square. Correct?
Yes, sir.
Okay. So what I have got is I have got an implicit relation. I have got an implicit relation between X and Y and a constant 25. And now I'm being asked to calculate the value of dy by dt. So what should I do? I should differentiate this whole thing with respect to t. Can you tell me what will be my right hand side if I differentiate it with respect to t?
0.
Yes, obviously it is a constant, right? Correct. Now x square, what will be the derivative of x square with respect to dt? With respect to t. So apply chain rule, it will be 2x into dx by dt, right? Everyone?
Yes, sir.
Yes, sir.
Plus, what about y square? How much will it be?
2y into dy by dt.
Correct. So now using this equation, first of all, I can cancel out this 2 and 2. So I have got x into dx by dt plus y into dy by dt is equal to 0. So from this value, I'll pull out my value of, from this equation, I will get my value that I am wanting. So can you just realize that the speed at which this below point is moving is actually equal to dx by dt. See, x is your length and the rate of change of length is basically speed, right? You have learned it in physics. Velocity is the derivative of displacement, right? So x is the length of this point, my base point to the base of the ladder. So how fast is x changing? The speed at which this point will move. So this is basically dx by dt. So when my x is 4 and my dx by dt is given to me as 2 centimeter per second. Can you tell me what will be, so y? Can you tell me what will be my value of y? Yes, I can find that out, right? It will be 3. See, it is something like this, right? So my value of y will be 3. Apply just Pythagorean triplet. It is a Pythagorean, just apply Pythagorean theorem. Pythagoras theorem, fine. So it will be 3 meter into, tell me, dy by dt, that is what I am asked to find out, is equal to 0. So this meter and meter will get cancelled, centimeter per second will remain. So what will be my value of dv by dt? dy by dt. It will be minus 8 by 3 centimeter per second. Right? Everyone?
Yes, sir.
Got it? So this was like a little bit tough because all we needed to do was that first establish a relation between x and y. After we got that, we needed to differentiate it. Then at a particular point of x, I needed to calculate the value of y also using Pythagoras theorem. And after that, I did it. Fine. Okay, so can you guys think of a solution of this question using physics? Okay, so let me just. Is there a possible solution of this using any concept of physics, rigid body motion? See, this ladder is a rigid body. Rigid, I hope all of you know what is meant by a rigid body, whose dimensions don't change. So let us give it a try using physics this time. So this is 2 centimeter per second. Fine. This is 2 centimeter per second. So this is 4 meter. This is 5 meter. Okay. 5 meter. This is 5 meter. This is 4 meters. So this will be how much? 3 meters, right? Pythagoras theorem. So I hope all of you know this, that since the length of this thing can't be increased, so if I assume this as center of mass, okay. So what will happen? I will take the component of the velocity along the line of the ladder. Same way, if this thing is moving down at, let me just assume it to be some value v. So if I take this angle to be theta 1 and this angle to be theta 2, so can I say v times cos of theta 2 should be equal to 2 centimeter? So this is 2 into cos of theta 1. Do you agree with this? Because it is a rigid body. So if it is a rigid body, its length shouldn't increase. So the components of velocity towards its center of mass should be same, right? Because its length can't change. So the component of velocity that is coming towards its length in both the cases should be same. So v cos theta 2 is equal to 2 times cos of theta 1. Can you just tell me what will be the value of cos of theta 1? Cos of theta 1 and cos of theta 2. Let's just do it fast. Cos of theta 1 is 4 by 5,
4
right?
by 5, sir.
4 by 5. And cos of theta 2 is how much?
3 by 5, sir.
Vignesh. Okay, great. So v into cos of theta 2, 3 by 5 is equal to 2 times of 4 by 5. So v is already told to you 8 by 3, right? Over here, your answer will come in positive, and I'll tell you why. Your answer is coming positive because we did not specify the direction. Okay, so that is why your answer is coming out positive. But the basic concept was that applying the fundamental of rigid body. So ladder is working as a rigid body. I hope you have done it in earlier classes in your physics. I guess rotational motion, right? Okay, fine. Okay, so let us give a try on one more similar cone question. So what is happening is you have got a cone, something like this. Okay. The semi-major angle of this cone is given to you as 30 degrees. Okay. It is already specified that the cone has this angle 30 degrees. And what is happening is water is being poured into this cone. Okay. So from the top, you have got a tap, and from that, water is getting poured in this. Okay. water is being poured into this. So it is asking you, find the rate at which the volume of the water increases. Okay. So rate at which volume of the water increases. Okay. And it is given to you that the height is increasing at 1 centimeter per second. Okay. Height is increasing at 1 centimeter per second. And it is uh, when the height is 24 centimeter, it is asking you what will be the value of dV by dt. Fine. Let us see if we can do it. So first of all, I have been given this cone and water is falling into it. So what I will do is I will assume any height. The water has filled up to any random height h. Okay. The water has currently filled up to any random height h. Can you tell me if I have got this height h, have I got the radius also at that point? The radius of the cone also have I got? Because the angle is given to me 30 degrees. Just a minute. See, this angle is given to me as 30 degrees. I know this thing is h. Can you tell me what will be the radius? Radius. If I assume this thing as r, can I apply trigonometry? Anyone? R by h will be tan of 30 degrees. What is the value of tan 30?
Root 3, sir.
Tan 30?
1 by root
1 by root 3. Okay. So do I know my radius also? My radius is how much? H by root 3.
Yes, sir. 24 by root 3.
Yes. So can at any so if I just assume that I have reached a water level h, so at that water level h, can I calculate the volume of the water that's been filled till that point? Can I do that? What is the formula? Volume of cone.
1 by 3 pi r square h.
So do I know the value of r and h?
Yes, sir.
So just fill it in and tell me. So pi by 3 into h into r square can be written as h square by 3. So it will be pi by 9 h cube. Correct? Pi by 9 h cube. So can you just tell me why I converted this thing to h and not to r? Why I did this question in terms of h and not in terms of r? Again, the same logic that we did earlier. The issue is that I am given the value of dh by dt and not the value of dr by dt. If I was given the value of dr by dt, I would have converted it to radius and did it. Fine. So I have got my value of volume. My volume is given to me as pi by 9 h cube. Can you help me and tell me what will be my value of dv by dt? Can you differentiate? So it will be dv by dh into dh by dt. Yeah. So tell me, what is anyone? Value of dv by dh?
Pi
Just
into h
differentiate.
square by 3, sir.
Pi
Pi by
h
3
square
into
by
h square.
yes,
3.
yes, correct. Pi h square by 3, correct, absolutely correct. Pi h square by 3 into dh by dt, right?
Yes, sir.
So in order to solve the question, that's what I needed. Is this all the stuff that I need to solve the question? I am just asked the value of dv by dt. I am given the value of h. I am given the value of dh by dt. So what I'll do is I'll just directly input my value. Pi by 3 into h square. H square can be written as 576 centimeter square, right? Square of 24 into 1 centimeter per second. So my final answer will be how much? Tell me. it will be 192 pi centimeter cube per second, right? Everyone got it? Any doubts? Again, this like I am doing just the same thing that I was doing earlier. I am just doing the same thing, repeating the same thing. I just assumed any height h. For that height h, I found out the volume and I differentiated volume using applying chain rule, and that is how I got my answer. Got it, everyone? Any doubt? Just ask if you have any doubt. Okay, fine. So we will do one such similar question related to rate of change of quantities. So over here, what is happening is I've got this lamp. Okay, I've got this lamp that's 50 feet height above the ground. Okay. So what is happening is a person, I've got this person who is that tall and he's 6 feet. Okay. His height is 6 feet. So at a point, he is, let us assume, how much? 10 feet away. This person is 10 feet away from this pole. Okay. So, and he's moving away from the pole, farther away from the pole at, I'll just assume any value. So I'll assume it at 5 feet per second. Okay. He's going away from the pole at 5 feet per second. So it is asked you that his shadow, how fast is his shadow moving? Okay. What will be the speed of his shadow? Okay. So what I'll do is, again, I'll do the same stuff that I was doing earlier. So this person is given to me 6 feet. This lamp is 50 feet. And what I'll do is I'll just assume any value x, that the person is standing at any random distance x. Can you tell me what will be the height of his shadow? Can we calculate the height of his shadow in terms of y? Is that possible? So I'll just assume this thing to be a variable y. Obviously, if I have got a lamp post over here and this is the head of the man, so his head shadow will be somewhere over here and the feet. So his shadow will be this long as the length of y, right? The length of his shadow is y. So can I calculate y? Do I have something? Both of these are similar triangles, right? Similar triangles. So I should directly just apply BPT, basic proportionality theorem. So doing that, I will get y divided by 6. So I'm just assuming this small triangle, y divided by 6 is equal to x plus y divided by 50. Correct? So I'll just send that 50 this side. So it will be 25 by 3y is equal to x plus y. So I will subtract it. So it will be 22 by 3 of y is equal to x. So can I write my y in terms of x? It is 3 by 22 of x. My length of y is 3 by 22 times of x. If I differentiate this thing with respect to y, with respect to t, so dy by dt is equal to 3 by 22 times dx by dt. Fine. So what is my dx by dt basically? What is, if this is my length x, what is my value of dx by dt? Dx by dt is how fast the person is moving. So obviously my dx by dt is the speed of the person, right? Dx by dt is speed of the person. So my value of dy by dt is 3 by 22 times the speed of the person. How fast is the person moving? 5 feet per second. So it is 15 by 22 feet per second. Fine. Really easy. Okay. Like all we needed to do is in general, in case of such questions, whenever you have got such a question related to rate of change of quantities, all you need to do is establish a relation between q, x, and y. Okay. And after that, differentiate it using chain rule or any other rule that you have. Okay, so let us try a question. So a lamp is 50 feet above the ground. Again, similar type of question. Lamp is 50 feet above the ground. A ball is dropped from same height from a point 30 feet away from the light pole. Okay, so a point that's 30 feet away. I've got a point that's 30 feet away. Okay, and obviously, a ball is dropped from here. Ball is dropped from here. So it will obviously follow your basic rules of gravitation. But this time, your ball is being set to fall at S is 16 t square. Okay. So your value of G has changed. Okay. So your value of G is 32, somewhere around 32 now. So it is telling you how fast is the shadow of the ball moving half second later. So when t is half second, okay, when your time is given to you as half second, what is the rate of change of shadow? So what I will do is, again, I will just create this shape that's been given to me. So obviously this ball will fall down somewhere half second later and it will create a line, something like this with the shadow, right? Great. So what I will do is, again, this thing is given to me 50 feet. So I will just assume that this height for the time being is some height y. This has been given to me 30 feet. Can I calculate my length of the shadow? Can I calculate where my shadow is? No, sorry, not the length of the shadow. Can I calculate where my shadow is, the location of the shadow? So what I will do is, first of all, I'll treat this thing as x and this thing as y. Okay. So can I calculate my y in terms of x? Obviously, apply basic proportionality theorem. So y by x will be y plus 30 by 50, right? Everyone, y by x is equal to y plus 30 by 50.
Yes, sir.
Is this thing correct? So 50y is equal to xy plus 30x, right? So I need to just separate out my y. So my y can be written as 30x by 50 minus x. Correct? Everyone got it? Tell me, any doubts in this one?
No, sir.
Okay, great. So I've just applied my basic proportionality theorem. So I've got two triangles and both of these were similar triangles. So that is why y divided by x is equal to y plus 30 by 50. So I just separated out my y and I wrote my y in terms of this thing. Fine. I just wrote my y in terms of x. Okay. So after half second, when t is half, can you tell me what will be my s? I can just directly put half. So 6 into half square. So 16 by 4. 16 by 4, how much? What is 16 by 4?
4.
Right? 16 by 4 is 4. Can you tell me what will be my value of x at that point? See, the ball is being dropped from 50 feet. Okay. The ball was dropped from the same height as the pole. It was dropped from 50 feet. The s, that is the distance it has traveled after half second, is 4. So what will be the value of x? 50 minus 4, right? right? See, it was dropped from the same height, and s is the distance, how fast it is dropping. So in half second, it has dropped 4. It has dropped 4. Okay, so 4 is the height that it has dropped. So what will be x? 50 is x plus y, right? So x is 50 minus
50
4.
minus x.
50 minus 4, right? Yeah, correct.
Yes, sir.
If it has dropped, so it will be 46. Great. Now let us give it a try. So x has already been given to me. So from this, can I calculate my value of dy by dt? Can you differentiate this thing with respect to t? So obviously what you will do is, first you will differentiate it with respect to x and then dx by dt. Can you differentiate y with respect to x? Can you tell me how can you differentiate y with respect to x? How will you do
Sir,
that?
division rules.
What will you do?
Can't we use division rule there?
Yes, yes. Apply division rule. Tell me the answer. So it's 30 times x by 50 minus x. So the derivative of the top, bottom as it is, minus derivative of bottom into top as it is, whole divide by bottom square. Is this correct? So 50 minus x plus x. So x gets cancelled out. So it's 1500 divided by 50 minus x whole square. Right? Right, everyone? Okay. So what I will do is I'll just substitute this thing back. So dy by dt is dy by dx. So I'll just substitute this thing back again. So it is asking me how fast the shadow of this ball is moving. So obviously it is asking me the value of dy by dt. Do I know the value of x? Yes, I know. The value of x is 46. Do I know the
46.
value of dx by dt? Do I know the value of dx by dt? Tell me. How fast is the x decreasing? Do I know dx by dt also? If you look closely, yes, I know. How fast is this ball falling at this point? This is a really great question. Like, can you think? Anyone? How fast is this ball falling? I know how, yes, I know what it is covering, how fast it is covering the distance. So can I differentiate this thing? What is ds by dt? What is the value of ds by dt? It's velocity, right? What is the derivative of displacement? It's velocity. So can you tell me what will this be? It will be 32t.
32
So
to
your v is
3.
nothing but dx by dt, right?
Yes, sir.
So this is your dx by dt. This is your dx by dt. So tell me, what is your dx by dt value? The t is given to you as half. So dx by dt will be 16.
16.
So just input both of these values over here. So you get 1500 divided by how much? 50 minus 46 whole square. So 4 whole square into dx by dt is 16. So my final answer will be how much? 1500 feet per second,
Feet per second.
right? Anyone, any doubt in this question? Anyone, any doubts? No one? Okay, fine. Then let us just try. Uh, Let us just try a few similar questions. Okay. So see, like all you need to do is nothing, just establish a relation between the quantity that's being asked to you and the variables that are being given to you. So once you do that, all you require is just do the differentiation and you'll get your answer. Okay. So you have been given an isosceles triangle. Okay, both of these sides are equal. Okay. And x be the length of one of the equal sides. Okay, so both of these lengths are x. And theta be the angle between them. Okay, so this one is a really, really good question. Let's see. Theta be the angle between them. X is increasing. Okay, so x is increasing at the rate of 1 by 12 meter per second. So can you tell me what will be my value of dx by dt? X is increasing at 1 by 12 meter per second. So it will be 1 by 12 meter per second. And theta is increasing. Theta is increasing at pi by 180 radian per second. Okay, this is how the theta is increasing. So it is asking you how fast is the area changing. When x is 12 meter and theta is pi by radian. Let us give it a try how we can do it. First of all, can you establish a relation between x, theta, and the area of this triangle? Can we do that? Do we have a relation? Tell me. Do we have a relation between x, theta, and the area? I guess we can give it a try, right? See, this is x, this is an isosceles triangle. So what if I pull down a perpendicular? I will pull down a perpendicular. So this angle will be theta by 2. If this angle is theta by 2, can you calculate the value of the height? How much is the height? It will be x cos theta by 2, right? And the value of this thing will be how much? X sine theta by 2.
Sine theta by 2.
So can you tell me what will be the value of its area? Area is half into base into height. So half into base. Base will be 2x sine theta, right? 2x sine of theta by 2 into cos of theta by 2 into x cos theta by 2. Height is x cos theta by 2. So 2 will get cancelled. It will be how much? Tell me. X square sine theta by 2 into cos theta by 2. So what I'll do is, can you tell me what is 2 sine theta by 2 into cos of theta by 2? What is the value of 2 sine theta by 2 into cos of theta by 2?
Sine theta.
It's sine theta, right? Yes.
Sine.
Apply half angle formula, right? So my area is given to me as x square by 2 into sine theta. Now it has given me the value of dx by dt and the value of d theta by dt. So what should I do? I should differentiate this thing with respect to t, right? I should differentiate this thing with respect to t. So dA by dt is equal to half times. So I have got x square into sine of theta. Can you differentiate x square into sine of theta? How will you differentiate x square into sine of theta? Tell me. With respect to t, how will you do that? Who will
2x
tell me?
sine theta, 2x sine theta plus cos theta x square.
Just a second. I am differentiating it with respect to t. I am differentiating this whole thing with respect to t. So 2x into sine theta into dx by dt will also come, right?
Yes, sir.
Plus x square into cos theta into d theta by dt.
Theta by d.
Correct? Correct, everyone? Okay, correct. So yes. So have I already got the answer? Yes. I am being asked to calculate the value of dA by dt. I have already got the value of x theta, dx by dt, and d theta by dt. What should I do? I should just input my value. So the value of x is given to me. The value of x is 12 and theta is pi by 4. So let us just substitute theta as pi by 4 first. Theta is pi by 4, x is 12. So my value of dA by dt is half into 2x sine theta. Sine theta, what is sine of pi by 4? Sine of pi by 4, everyone.
1 by root 2.
1 by root 2.
Great. Why is it taking so much time? Plus x square. X square will be 24 square.
24.
Cos theta is 1 by root 2 into d theta by dt. Correct? So what I'll do is I'll just take 1 by 2 root 2 common into. So 24 into dx by dt. Can you tell me what is the value of dx by dt? It is 1 by 12
1 by 12, sir.
plus 24 square. How much is d theta by dt? Pi by 180. This is my final answer. This is my final answer, everyone. Okay. So all I need to do is just ease up the calculation. So it will be 1 by 2 root 2 into 24 by 12 is 2 plus 24 square is 576. So 576 by 180 divide by 9 directly. So 144 divide by 9, 20. So what will this value be equal to? Will it be 7.2? 7.2 pi, right? 7.2.
Yes, sir.
This value will be 7.2. Okay. So my final answer. See, like the answer is a little bit tough in writing, but actually the question was not tough to solve. 1 by root 2 plus 3.6 pi by root. Okay. So it's 1 by root 2 into 1 plus 3.6 pi. This is my final. Okay. So this was just a little bit calculative part. Okay. So one last question before moving, before going. So I have got an observer. Okay. I've got an observer over here and a helicopter is rising vertically above. Helicopter is rising vertically above. So at any point, this person is seeing the helicopter. Okay. And he is telling at an angle pi by 4. Okay. He is telling that the rate of change of angle, this angle, if I assume it to be theta. So the rate of change of theta is, I'll just assume it to be some value. Okay. So pi by 180 radian per second. Okay. Pi by 180 radian per second. So now it is asking you what is the speed of helicopter. What is the speed at which the helicopter is rising? Okay. So fine. And this thing is given to you. This thing is already given to you. It's 50 meters. Okay. It is 50 meters. Okay. So just a minute. Okay. So again, what I'll do is I'll again write it like this. So what I'll do is I'll assume this thing to be X. This thing is already 50 meters. And this angle is theta. Can I get a relation between X and theta? Can I get a relation between X and theta? What is the value of X divided by 50? X by 50 is tan theta.
Tan theta.
Tan theta, sir.
So X is 50 times tan theta. Right? X is 50 times of tan theta. Do you agree with this? So if I differentiate it with respect to time, so dx by dt is 50 times. Tell me, how will you differentiate tan theta with respect to t? How will you do that? So you need to differentiate it with respect to theta first. What will be the derivative of tan theta with respect to theta? Derivative of tan theta. Yes. Correct. So it is asking me the speed at which helicopter is rising. So can I directly say that dx by dt is the speed at which helicopter is rising? Right? Can I directly say? Because x is this thing. X is the height at which the helicopter is. So obviously dx by dt will mean the speed at which helicopter is rising. So what I'll do is I'll just directly input my value of theta as pi by 4. Okay, if I do that, it will be 50. What is the value of secant of pi by 4? Secant square will be 2, right?
2, sir.
And
Secant square.
and dt, okay, great. Into pi by 180. This is my answer. So 100 into pi by 180. This is my answer. So 5 by 9 pi. And can you tell me what will be the unit in which I'll be getting my answer? What will be my unit?
Sir, rad by second.
How much? Radian per second. The speed of the helicopter. See, I'm measuring the speed of the helicopter. It will be meter per second, right? Radian has no, like, if you multiply, okay, so like just one small point. Radian is a unit, I know. What is the dimension of radian? Dimension of radian is m0, l0, t0. So don't get confused, okay? So if you multiply radian with meter per second, it will still remain meter per second. The units won't change. Okay, that is why I'm getting my answer in meter per second. Anyways, it is more on the physics side, but the velocity will come out in terms of meter per second only, not in terms of radian per second. Okay. So that's it for today. Any doubts in today's class? Anyone? Any question? From tomorrow onwards, we'll be starting with tangents and normals. I hope you have done tangents and normals in conic sections. Have you done tangents and normals? Conic section.
No, sir. Conic section is on master.
Yes,
Acha, conic section is not done. Like, okay, I thought
Yeah.
Kevin sir had done that. Okay, fine, not an issue. Okay, so we'll be meeting tomorrow. Okay, bye. Ma'am, can you please end the class?
Yes, sir. Thank you, sir. Students, you can
Students, please
join
join the next session.